Hello. Good morning. Wow. So it's pretty early for a Friday at such a conference, I would say. So I appreciate that even more that you take the time to learn about the graph and subgraphs on Avalanche. Let's start quickly. Who of you knows the graph? Okay. Who has wrote the subgraph before? Okay. All right, then we can do that together. So, quick repetition about on-chain data. I think about on-chain data as it's more or less a table, it's static data. We speak about the chain head and the state of the chain, and when we look, for example, at the CryptoPunks or any other NFT, what the smart contract really well knows who owns which NFT right now. What the smart contract not really knows, it kind of knows who owned it before and what was the price. It's just how it is. Like every time an NFT moves, then there is a new transaction, and then the blockchain keeps track on the current state. Everything, the history is there, but where is that history? So we want to have like this provenance, especially with NFTs, where we can go back and see like who owned it before, or like what was the price it was traded. But in order to do that, it gets a little bit more complicated than just querying the contract for the current state. That's what we try to do. So that problem with that data, again, is that the blockchain also is not incentivized to give us that data. Like when we send a transaction to a blockchain, we pay some transaction fees, and that incentivizes the miners or the validators to bring that block into the chain, and that's how it's there. So we have a whole incentivization system around writing to the chain. But if you want to read from the chain, then we can try to ask some JSON RPC provider about the data, and with JSON RPC we can also only it's like not a very optimized protocol to get data out in bulk, so we can ask some nodes about maybe events that happened, but like there's no incentivization mechanism. Now there is a huge marketplace of JSON RPC providers and data providers in general, but most of them are just a centralized solution for a problem that should be decentralized, in my opinion, because like the data is the goal, or is the oil of the new century, and it's very important that we know that which data we can trust when we go to an exchange and we want to see how the prices develop. We kind of want to be sure that like that chart is not wrong. That's not wrong data. It's actually true data. So we need to have like some security on top of that. But when we look at the blockchain, like all the transactions, they are just like one after another, and all the different protocols on the same chain, they actually have a mess. Like it's all together in one chain. I know, like in Avalanche, one of the solutions here are the subnets. We will go into this, but on C chain, it's the same. We have just like all the transactions on top of each other, and we want to find out, like, oh, actually, what happened on Trader Joe. Then we need to go through all these transactions and look at the transactions that Trader Joe, that are from Trader Joe's contracts, and kind of throw the others away. And when we still use JSON RPC, we end up with a code like this. So who knows about JavaScript? Who writes JavaScript? I mean, you don't need to love it, but like a lot of people know it, right? So we end up with code like this for a simple thing that is like, give me all the tokens from that owner. So we need to go and query that contract and then see like how many tokens does he have, and then we loop through that, and we see that all these are waits. There are asynchronous calls to the JSON RPC endpoint. All of them take 300 to 400 milliseconds to resolve. If someone has 10 or 20 NFTs, this code runs for several seconds until we can just simply display like which NFTs that address owns, right? And that's far from optimal. And actually now that problem space that we just described, like decentralized data, fast access to data, an incentivized also a layer for serving and storing data, that's what the graph basically does. So when we go back to that architecture diagram from before, like we have the front end or the dApp that want to query data, and we don't go directly to smart contracts anymore. Like there is a data layer in between that's a subgraph. and we go deeper into what a subgraph is. But basically, the subgraph holds all that data, kind of also curated for us, so that we can quickly display it on the front end, or in any data analytics use case that we have otherwise. So from that weird async code, we can go to this very beautiful GraphQL query that just gives us this one request, all the NFTs or all the data and information that we need on the front end or in our other data consuming applications. That's very beautiful. Yeah, that's GraphQL. Who knows about GraphQL? Yeah, I love that language. It's really like it's a beautiful way to explore APIs, and that was a big step in my career when I learned about GraphQL and could finally have like a nice API that can explore and gives me that stuff. Now the graph is a decentralized network. I quickly touched before. So there are like over 448 indexes. That number goes up. We have delegators and curators, which are not so, we don't dive deep into it, but like also 803 subgraphs are deployed to the decentralized network. There's also like a hosted service at the moment, and there we currently see like around 1.5 to 2 billion queries a day. So the graph really powers like the biggest applications in the space. And on the decentralized network, we saw until now 2.25 million GRT in query fees since the network launched maybe a year ago or so. And so in the end, like what the graph enables is truly decentralized apps. So we have like a decentralized data stack, and we can have this this worldwide like redundancy of indexes that gives this high resilience. Like also when we query to the decentralized network, we go to an index that is nearby, that can have like a quick response time, and also if one goes down, another is there. So that really gives this resilience, like similar to the internet, right? The internet also is a decentralized network, if you want, and it also, I mean, almost never goes down. The only thing that can go down is our access to the internet, like when Wi-Fi doesn't work. But it was pretty good at this conference. So there are dApps now migrating to the decentralized network. It started with Ethereum, so here are mostly Ethereum logos, but since several months, we are also Avalanche seed chain is supported on the decentralized graph network. And so now we can really bring these subgraphs over from the hosted service to the decentralized network. So that's amazing. So if you're interested in bringing your subgraph over, find me and we can set up a working group. There are migration grants that also help with that migration. Definitely something cool to do. A quick note on Avalanche subnets. So we touched it before. So if you think about creating a Avalanche subnets, it's like currently the support on the host service or the graph network for the subnet specifically is not there. We are working on this currently, but there are some workarounds. So for example, we could self-host a graph node that indexes your subgraphs. We go into the subgraphs, but then the network needs to be, like the subnet needs to be EVM compatible. Some subnets, they don't necessarily need to be EVM compatible, which is good and bad. It's good because like we have more flexibility in how to build that subnet, but it's bad because then maybe some integrations will be more complex. But that's also possible with the graph. There's a technology called Firehose, which is blockchain agnostic and can bring data quickly into the graph and other data solutions. So if you want to go that route, again, reach out. There are possibilities to do that. So, what is a subgraph? We talked a lot about subgraphs before, but basically a subgraph is an instruction set that we see. It's a database schema. We define how a database looks like how we want to have actually the data that we need, how we want to have it stored. So in terms of like Trader Joe's, they have like one table with tokens, and then one table with pairs, and then one table with trades. And that's how the whole thing then starts to build up, right? And then we have an instruction set, that gear on the bottom, that knows how to fill that database. So that's called the mapping. So the mappings, they look at the blockchain, they look at the events, they can also go into transactions or calls. And then whenever something happens, starts to store stuff into the database or removes it from the database. So that, so in the end, what we end up is like a highly curated database. So we go from this mess where everything is together on the same blockchain into like well-curated databases per protocol that we can influence how we want to set up this database and what we want to store in there. So again, like, and in the end, we can query that database with GraphQL, also SQL access. It's something that is currently discussed and more. So that's a very powerful way to access that data. And then, as I said, like the architecture changes from user interface on the top to then we have an indexing protocol that serves that data. For reading, and for writing, we still go directly to the blockchain because there we have, we have the incentives properly already, right? So how does it look like on a technical level? So on the top, we have the DApp or the consumer. And then we send transactions to the smart contracts. When we do something, we want to trade an NFT, and that emits events. And then the graph node indexes these events, catches them, writes into the mapping module, like it's compiled down to WebAssembly, and then stores in a database. And on the left side, when we query then, we can query through a GraphQL API directly to the graph node. So that's roughly how this works on a technical level. Or this is like a little bit a nice GIF that we have that explains like what's actually happening. So we have this mess of different transactions, and in the end, kind of magically, they are just ending up like being well sorted. Cool. So if you want to tweet about that, you just learned about subgraphs. That's the slide that marketing gave me. So, but like no pressure. I see some people do it. Thank you so much. And yeah, but I would say like better is to just do it together. Now another QR code, I know, like this QR code brings you to a GitHub repo where like all the stuff that I do it quite quickly right now is like explained in full, and I see that one is more interesting than the Twitter button now. That explained in full how it works and how we and also how the code looks like and everything. Yeah, so that's this one. I mean, roughly the steps is like we need to install the dependencies, we find the contract and the API, then we initialize the subgraph, we can create the subgraph already, deploy, and enhance. But let's just do this together. So when you go to, I should maybe increase this a bit. Yeah, that's good. Okay, when you go to the graph.com, there is a product here on the top left, and it's we go to the Subgraph Studio. So the Subgraph Studio is the way to go for all these chains enabled on the decentralized network. The hosted service is still around, but will be phased out over the next couple of months. So when you start fresh, go to the studio. Then we can connect with a wallet. We have like MetaMask, but also Wallet Connect, whatever you like. And we need to sign that message. And then we can basically create a subgraph. So we can do the small show subgraph here, right? Then we go, then we take Avalanche as a chain and create the subgraph. Nice. That needs to be bigger too, huh? More? One more, huh? Okay. Cool. Then the instructions here, basically we can just follow these instructions. So we had like graph CLI installed, and then I can just like graph init studio small show subgraph, so we can do that. Then we choose the protocol. Is it big enough? That's too bigger, huh? All right, now it's good, huh? No? Okay. The bigger the better, actually. Okay. So we go for the protocol Ethereum because like it's EVM compatible. Then we give a slug, and the slug is predefined. Then we can just create there is a directory. We can go here and find Avalanche. Where is it? Here. Then we need to have the contract address. So in that example, we already have a contract deployed on AVAX. And yeah, maybe let's look at these small shows here. So we can just click here, go to the Snowd trace, and then we can get that contract address. So we just copy paste the contract address over, paste, tries to fetch the start block. Sometimes that doesn't work. Then we can just go into the transaction and see at which block that contract was deployed, so that the subgraph doesn't need to start earlier. It makes it faster. Yeah. If you start too early, like then it's just like the subgraph will start to index a chain with, let's say, block 0, and then until, how much is this? 16 million or something like that, just like nothing. Tries to find events that are not there. Yeah. So like that's the contract name. And then here some magic happens. So we can just say like all the contract entities that contract emits, I want to auto create some code that indexes it. So let's do this. Cool. We can already in the background actually, oops. Subgraph, look a little bit at that code. So the subgraph basically consists of, it's a Node.js thing, so it consists of a package JSON, so we have some commands defined here. I start looking at in the subgraph YAML, that kind of holds it together. It's the manifest. There we see like, okay, that's the contract that we want to index, that's the start block. These are the entities that are created. And then also the event handlers is like, for all these events, we have a handler. Then we have a schema, that's also defined here, somewhere. Yeah, here we have the schema file. We can look at the schema. In the schema, it's just like a database definition, how we want to store our data. So we see like for every event, so like the transfers are the ones that are interesting with NFTs. We have like an event ID, a from, a to, a token ID, then a block number, a block timestamp, and a transaction hash. So we can then order by historically correct and so on. I think, yeah, there is a problem currently with my computer, but I know the workaround. I just need to use npm instead of yarn. And then the next thing we can look at is the actual mappings. That's where the magic happens. So that's assembly script code. Assembly script reads very similar to TypeScript, but it's a little bit different. So there are small differences with assembly script. So keep in mind if you write these subgraphs that like there are some small differences. But the cool thing is otherwise it works very well. We have like the usual stuff like auto completion and so on and so forth. But first it needs to install. Yeah. Okay, that takes too long. We can skip this because I prepared it. Let's test. Okay, basically the same thing. Okay, so what I wanted to show here is like after we write this code, graph code gen, it auto generates like also boilerplate code, and that we can inspect. So like what I do is like on the Mac with command click, I can go into these entities and start to explore them. So we see like, oh, okay, there's this event, and then we can see, okay, what do we have on an event? We have an address that emits the event, and so on and so forth. So that's how we can start to explore the code and write our subgraphs. But we don't need to go too deep into this because like the boilerplate already is quite useful in my opinion. So let's see what the next steps are. So I can now just authenticate here. And so like my CLI is authenticated to the Subgraph Studio. And then I can just deploy that subgraph. I give a version, so best practice is to follow semver and go maybe with these minors first until we have a really a final version. Then we can go to version 1 and then deploy to or publish to the decentralized network. But now that subgraph is already here. See, it jumped directly to 100% because it's the same as I tested out before this morning. It takes a little bit longer to index, but like we can now start to explore the data. So we have like here a graph called Playground. On the right, we can open up the Explorer. And that's the beauty about GraphQL because it's so heavily typed, I can just start to explore it by myself. So we can again look at transfers. So we can say, okay, let's see the transfers, which block number from to, which token IDs, then maybe order by block timestamp, descending. And you see, we can here just click everything together, and on the left side, the code is automatically generated. And then I can send this query, and then I see like all the recent transactions, how this NFT moved around on chain. Boom! Took me 5 minutes, and we can now already use that endpoint when we go here, the development query URL. That one we can bring into the front end or just start here. We can also just go directly here, have another Explorer, and now we can start to query our contract. That's it. Yeah, and then later on we can start to improve here. We can say, maybe we want to have like different entities. We don't want to have everything stored. We only want to focus on the transfers, but I also want to see about the users. So whenever there is a transfer, I maybe create the user and so on and so forth. Like all these patterns are described in that GitHub link that I provided. But I wanted to show you something else here also. So now we know how to write subgraphs. And we can write subgraphs for our own depths, but a lot of people are mostly interested to see like what's already there, right? And there is so much cool stuff going on the blockchain, and it's all transparent. We can look at everything, but the problem is that we want to be able to compare the different protocols, like the different metrics about those protocols, like what's TVL, what's revenue, how many deposits they have, and so on and so forth. And then, until now, we were looking at different data sources, and so we found data source A, which was pretty good on TVL, but like did not really have information about these other metrics that we want to track. And then there is data source B, and it has a little bit more stuff, but like also not complete. Then there's a data source C. It's again different, and in the end, we end up with still gaps and even conflicting information. So the Messari team, from them I stole that slides, are a core dev that also joined to work on the graph protocol, and they want to fix that problem. So the idea here is that we have subgraphs or data sources that are comparable across all the different protocols, and then we can start to really look at it and uncover trends and so on and so forth in a good way. It's all also documented and laid out. And so they have like their data apps that we can see on when we go to the Messari website. We have these data apps on top here, but also that's the. And also there is a protocol metrics explorer. We can look into that quickly. So yeah, we have like great coverage around the most adopted apps. Like it's really the most important ones are there. There are more than 90 subgraphs already finished. 300 are in the making. The schemas are standardized. Like for all these protocols, they have the same. Like if you look at lending protocols, it's always the same schema. So we can send the same query to different subgraphs that then give us comparable data about about these protocols. And then in the end, we don't even need to write these subgraphs. They're already written by the Messari team. We can just use it, right? There's a cool list of these subgraphs. So it's subgraphs.messari.io. Maybe I need to. And yeah, let's see. For example, Trader Joe, it's here. So we can see that it's here. Then we can click on that button, click here, and then we end up on the subgraph. That one is on the hosted service, but there are also subgraphs on the decentralized network. And then again, we can do the same. We have like this explorer here. There is some queries already here. We can start to explore, see like, okay, what we have are, we have liquidity pools, we have reward tokens, swaps, and so on and so forth. And that for most bigger protocols that are available. So really cool, check it out. Subgraphs.messari.io, yeah. Yeah, and they also have like subgraphs on a decentralized network, as I said. We can quickly look into how to query a subgraph on a decentralized network. So here, we need to find one first. And that's the graph.com. Actually, I need to do it here. So I'm here, and then I can move to the Graph Explorer. So now I can see which are the subgraphs that are already on the decentralized network. We can look maybe at CryptoPunks. There is a subgraph from Messari tracking the CryptoPunks. Again, we have a playground, we can play around. But what we really need to do is like we need to have that query URL and API key. When we look at that query URL, I know that's probably a little bit small, but like there's an API key placeholder in here. So like the next step would be to go to the studio and go to the API keys, create an API key. The first 1,000 queries are for free. Then we can use it and paste it here. Now, we need a graphical tool. Yeah, and then we have the subgraph here. So that's how to query on the decentralized network. It's not that big of a step, but it's good to know. Yeah, I think we can wrap it up here and have some questions. Thank you so much for joining me this early on a Friday morning. For questions, please raise your hand and then the microphone will come to you.
Morning and well done for being the first session of the day. Sorry, just a simple question. When you created the subgraph, where was it pulling the data from, and what was the cost of that?
Yeah, that's a good question. So if you publish a subgraph to the decentralized network, so there is these 500 or 400 indexers that are then indexing your subgraph. And they have actually two possibilities how to get the raw data. So one is like most of them currently run an archive node. They need to have an archive node. They could also just like pay someone to run the archive node for them, but it's usually too expensive. So for them, it's cheaper to run an archive node by themselves. And then access that data with either JSON RPC, or there is a new technology that's coming. It's called Firehose that I quickly touched on with the subnet integrations. And that Firehose is much more efficient to blast that data out in bulk. So it's kind of a reinvention of JSON RPC. But that's roughly how this works. And you probably think about the payments. So by paying per query, the indexers are incentivized to index subgraphs. And there is more around it, like curation and indexing rewards and so on and so forth. But like that's more technical about subgraph development and not about the graph network it works. Otherwise, I couldn't do it in 30 minutes. Yes?
Thank you for this. Probably the best presentation I saw in this entire summit. No offense to anybody else, but for me personally, it was amazing. Just one part, as a developer, I didn't understand. this magical part when you give the contract address and the block number, and suddenly it knows how to handle some contract. Like, what if I have some like custom smart contract that's different? That's not RC721 or something.
Yeah. Okay. So what I did here, it was a little bit quick. We see that the contract is verified, right? So the CLI goes to Snowtrace, asks for the ABI, downloads that ABI, and then according to the ABI starts to build the scaffold out the subgraph. But what I want to say, yeah, you don't necessarily need to verify the contract on Avalanche on Snowtrace. We can just supply the ABI during the initialization process and say like, here's the path to the ABI, and then that ABI will be used. So that's another way. It's just easier when it's verified to show actually.